The only thing I find more inspiring than a great museum like the Smithsonian is getting to witness behind the scenes at a great museum like the Smithsonian, and that is where we are right now. I'm standing at the overlook, and behind me what you can see is the Mary Baker Engen restoration hangar, where the Smithsonian repairs, restores, and prepares for display all of its amazing artifacts. And there are some amazing artifacts to view down here, but the particular area that we are concerned with today is way over in that corner, where I can see from here a command module, which I think is from Skylab, and all the other collected space stuff. We're gonna get a close-up view of all of that. All right, Lisa, this is your domain here.
Right, this is the conservation world of our restoration hangar, so.
And will you give me a walkthrough of what you guys have on your desk?
Sure, I'd love to.
Okay.
On our desk. Yeah, we're down here because everything's a little bit bigger than we usually work on. So this wonderful piece that Jackie's working on is a LEM cockpit simulator. So they would have used this to train in. Grumman actually, that's all original equipment, some instrumentation, buttons, pieces, bits and bobs.
Yeah.
They built this frame and actually had it in their environment before it was donated to us. So in the new display, which is going to be super cool, these windows where you would have trained to look at, you know, coming in with the LEM and everything, we're going to have movies put in there of the original footage. So we are not replacing any parts. We're just sort of cleaning up what's here, looking at the different materials. There are some sections which have suffered over time, which we're going to replace with a replica piece, but then we'll save the originals in storage.
Now, when you are conserving, quote unquote, conserving this, how are you deciding what to clean and what to leave dirty? How do you make
this
those
one's
decisions?
a little easier because it was on display for 45 years, so it does have a lot of museum dust. And we know it wasn't in space. But if there's wear to any of the materials, like this is sort of one of my favorite parts, is these disky keyboards. You can kind of see the fingerprints still in there. So Jackie's just used her knowledge in conservation science to decide what kind of treatment she can do, wet or dry surface cleaning, how that would interact with the materials we have, and then what's best to keep things in place. So this like yellowed plastic, for instance, over paper, we're not going to do anything to that. So you'll see a lot of discoloration and wear still. The Velcro, it's all original. We have things stuck here and there. These beta cloth bags, which are amazing, you know, NASA labeled everything. So it's like really cool because, you know, we'll put foam supports in there and try to put them out. But yeah.
When does this go out? When does this leave your...
So all of these stuff in the Conservation Annex right now is scheduled for the 2022 opening of Destination Moon, which is the permanent Apollo gallery we'll have. And Neil Armstrong's spacesuit and the command module will be the centerpiece of that new gallery together for the first time. And then we'll have all these other pieces, and they're representing Apollo.
That's awesome. But if you don't mind, could I take some pictures of this? For
my
own, yeah, because this I recently got a beautiful Disky replica that's functional. So you can actually program with it, and this strikes me as a really good replica I might want to tackle.
Yeah, we have pictures too, so we can give them like high res.
Oh, nice.
So over here on the table we have the passive seismic equipment that actually we have a picture of Buzz Aldrin carrying that famous picture of the two wonky experiments onto the moon, and this is one of the test models. We've had this on display for a while. So one of our bigger conservation challenges you'll see on all the objects down here is like re-adhering what people think is tinfoil. But it's kept on. So they used all these sort of materials to keep radiation off, you know, for thermal exchange, for heat dissipation. And we're left now trying to really get it to lie back down the way it was, to show the crinkles in it. This gold, where they have gold sort of embedded in the mylars and aluminized pieces, are the kapton, is what NASA refers to as kapton. And you'll have copper ions in there or anything else embedded in that. They used it for tapes all over. It's actually inside the spacesuits. That's how they taped all the layers together of the mylar.
I did not realize that.
And that's where it pulls because you can't get it to move anymore. So when they were wearing them and those aluminized mylar layers pulled, we are seeing some disintegration. But later on, ILC tells me that they actually learned to crinkle it so it had more play.
Wow.
So they came up with a crinkling method I know, to make it work better. So you can see that here. So all of these are very unique materials for conservators we're not used to. So we have to use our conservation science. David, who's working on this, traditionally works on trophies and other pieces. He worked in Colonial Williamsburg for a long time. We're lucky he's here, but like now he's having to do space stuff. So it's always a learning experience for all of us together.
Yeah. This, I'm trying to not like geek or freak out about seeing the lunar rover
Or sit in, right?
I know I can't sit in it. You know that I want to sit in it, but
I know.
I know that I can't. I've accepted
I knew
that.
you would want to sit in it, so I specifically told them, don't ask to sit in it. So this is one of the test models that they used in New Mexico prior to training for the lunar rover flights in Apollo. Everything on it's practically authentic. We have the cameras and things off now because we're conserving them upstairs.
And it even has a spare tire.
Yes. So this is about to undergo a 3D scanning project, which is super cool. And so we pulled the other tire that's also going on display out so we could compare some things because we didn't want to take these off.
Okay.
The tires are really funny because they're spring-loaded and they're on some weird axle system that no one quite understands or has access to the manuals for, so they're going to scan all the different intricate pieces. So they didn't ride...
You mean what goes on inside there?
Yeah, they didn't ride exactly how you would ride in a cart. It's like hydraulically driven, and then we're still trying to figure out sort of all these pieces. But this is sort of a great engineering feat that they came up with, and then you know, as soon as we ask people, there's no answers for why it worked that way. So, and it doesn't have like a straight axle. They all operate on 4 different mechanisms.
So each one is individually controllable.
Right.
And
so it's pretty cool.
That is really cool. And these wheels, they wouldn't support the car on Earth.
Oh no.
Right.
These are very tiny, and we actually learned that this is actually piano wire.
Oh, is it?
They coated.
The screen is piano wire. Wow.
Yeah, it's a zinc-coated piano wire, so it's very light. We never would display this. Right now it's on a shipping crate, and we're using it we're going to build a stand for it for the new display, but we would never let them rest on those wheels. Right.
Because they were made for 1/6 gravity.
Right. And this apparently just popped out of the LEM, so it folds up and crushes up into a little square. And
I've seen pictures of the crushed up one, and it blows my mind.
I know, I'm still trying to figure out how that happened. It's pretty cool. Yeah, just coming around, we were told these were original lawn chairs that they used and designed to work on the lunar rover, or to make it work. And there's sort of pieces like that all over, just like the model you pointed out. It's like, what worked at the time?
Right,
like, what do we have that's going to work up there? And so...
It's gorgeous. I love the antenna, too.
Yeah, that's really amazing. And there was a previous repair in here, and Lauren has actually stitched it back and tried to repair it. We didn't replace any of this netting. Wow. And then she stitched up some other tears that had gotten in it over time, just because it's so fragile. All the materials, because they didn't have to be heavy duty up there.
Right. 1/6 gravity, you had a lot more latitude.
Yeah.
Wow. I can't believe how delicate this mechanism all is.
Very cool.
I was trying to figure out why this was so big, but of course this is a seatbelt for someone wearing a spacesuit.
Right.
So it's this big pad there.
And the A7LB was even bigger than the earlier suits. Yeah. And the backpack. Right. So there's this weird space, and we were like, what's that for? Right. The life support system.
For the PLIS.
Yeah.
Yes.
Back here is the tool carrier that came off the back of this, which you might like. It is super fun.
Oh, yeah.
It's like an imaginary backpack for tools.
Oh.
And it's really beautiful. Like we've seen nothing like this. And, again, all labeled, every little intricate part, wrapping.
So NASA did not have the little, beautiful labelers that we can go buy at any stationery store now.
So I was told.
How do they do these?
I was told, and I could be wrong. Well, the fabric ones were typed on. Right.
Yes.
So that from the spacesuits and things.
And I knew the spacesuit labels are rubber stamps. The name tags.
Yes. They did rubber stamp on there and used a typewriter.
But I'm curious
I'm not sure what they would have done with that. It would have probably been a graphic somehow.
Oh yeah. I guess it's.
They're all stuck on. So I don't know if it was like a stencil at the time.
Yeah.
Where they, you know how they can get rid of like the part around where it's like they scratch through or, but they are like metal foil taped on, adhered on pieces.
Oh, this is great. Dust brush, interim stowage.
So we're going to
so cool.
install some of the tools for
You
the
are?
new display. Yeah. That was part of our deal. And we have it off there because we're cleaning it separate. But yeah, see, they would stick it down here and it would stay in there. I mean, this is just
this is the orientation it was
amazing.
in. It was this up. This is upright.
It would just been attached to the back of the.
Making some of the moon tools is something I eventually will get to. I was actually taking pictures of your brush out there in the main thing because that's I love the specificity of all the little shovels and brushes and grippers and grabbers.
So this is the lunar orbiter,
Right.
which mapped the lunar surface to find the landing site. And Rachel had some conservation issues on here, which were unique to us, but not unique overall with space materials because our Velcro is actually showing a lot of signs of aging in here. And prior to that, I'd never seen really the Velcro causing a problem.
Right.
So Rachel had to come up with a technique to actually consolidate the fuzzy part of the Velcro back down because it was shedding.
Oh.
It's nylon, but it has a fire retardant in it because all the space Velcro was made separately, and we corresponded with those companies a lot. You know, we work with industry just like you do, so we were curious about things. But the real issue came when she wants to reattach all the blankets that cover this. So there's blankets that would have been on this in space.
So the Velcro has a utility for you.
Right, and we can't attach to it anymore.
Right.
So she came up with a system to attach an inner sort of piece that's going to have magnets on it, and then we're going to embed magnets in the blanket and sort of get everything attached together, looking like it's attached to the Velcro. But the Velcro, in her opinion, and then watching her work on this, is not going to support any more attachment.
So, and what you mean by that is that if you did try and attach it, you'd be yanking loops out and just ruining it more every single time.
Just making it worse, and it could pull off. But it's mostly this fuzzy part that's just shedding. So she's done a chemical treatment on this actually, and so you don't see the shedding right now.
Right.
And it will be sort of horizontal in the gallery with its solar arrays out. Right now it's on a stand, and we have to raise it up and finish the treatment. And so the Corona camera would have been the right direction and all. And it's going to be hanging near the ceiling. So we debated sort of doing a bunch of things because no one will really see it up there.
Right.
But then for us, we knew if we wanted to remove the blankets to monitor it or to get a piece or even treat it again, we didn't want things,
So the whole goal is always just to stop what's happening in its tracks.
To slow it down.
Yeah.
Never quite achieving stopping, but slowing down, definitely. Slowing down those aging processes, just like us all, right? I mean,
when this mapped the surface, did it have a camera? Is there a camera on board, or was it?
I would have, yes.
Okay.
Yeah, here's one of the lenses.
Oh, okay. Wow. Well, I recognize this is a command module.
Yes, one of them, and it's Skylab, which is a little different because I'm used to working on Apollo.
Yeah.
So this was the last one, as I understand it, that they used for the program.
Okay.
Before they transitioned. So Skylab 4. Same configuration as the Apollo ones, but more refined because they got their techniques down.
Right.
The earlier ones, especially Apollo 11, the heat shield is just really bulky and overproduced, and a lot of stuff happened on the surfaces because they weren't sure what was going to happen during reentry.
Right.
So now they've really refined the process. This one did undergo some testing when it came back by NASA. But yeah, there's a lot of cool features on the command module that people always have questions about.
And you guys are getting this ready for display?
Yes. So this is going to go out on loan to another museum.
Am I looking at places where bolts were?
Right. So all of these equipment bays would have held the environmental equipment, the fuel, all of their stuff that they could have accessed through EVA. So they had these bolts. Originally, they would have had little covers that actually were made out of a cork material.
Yeah.
Which they're still on the Apollo 11, and we could not believe that they used cork, what was a cellulose with polyethylene beads in it when we analyzed the material, and they would plug them up. And so the astronauts could pop those out easily with a tool, and then the bolt would keep the equipment intact. But obviously the bolt hole covers have been removed from this.
And will you put them back in for display?
No, we don't have them.
This
is just the way it came.
Oh, okay.
So have some features going on here, which people ask me about. So these are the pitch and yaw.
Oh, right, yeah. Psh, psh.
Nozzles, which you'll see all over. This is an S-band antenna.
Oh, okay.
So there's 4 of them on the heat shield. Some got more burn than others. It's actually like a silicate glass material, which is quite fun.
Oh, yeah.
And then this is just the ablative heat shield.
Right.
But the interesting thing about here, and this shows a lot of good things that I learned on the other one, so all of these little marks are pre-flight repairs. So after they filled each of these little holes by hand, 370,000 holes with cocking guns. These women filled every single one of these little spaces. They put the heat shields together.
These little honeycomb.
Yes. And the pictures are amazing, the archival pictures of them doing this.
So
they just sit around, you know, all day long, filled it up, formed it, and then put it in a curing oven for a few days, pulled it out, and then they did radiology on it, and they could not have any kind of airspace or air pocket or any blip in their system. So they would drill out.
Oh, so
all
each of these
are pre-flight. I thought NASA, on the first command module I ever worked on, I thought they had done all this when it came back. And even these square pieces, I mean, they're just amazing little features.
These are all repairs to get rid of any voids within the heat shield.
All over. And they took
wow.
so much time doing this.
No, that's crazy.
So aren't they fun? And so all these pieces were made from like original heat shield, and they would just drill them back in and put them in. Yeah, so I often get a lot of questions about the little circles all over the heat shields.
That's crazy. And so they were able to cross-reference the x-rays that they were doing, or the...
Yep, and they marked everything, filled it up, re-cured it, and then started their coating system, which involved several pore fillers, epoxy boost cover, which you can see here, this white, and just, you know, that's how they formed the entire heat shield. So both pieces are made out of the same stuff. This is just a thicker, more ablative material that would have been meant to ablate off, whereas the central heat shield was meant to stay, to protect the inside cone.
So when you say they were caulking everything, were they doing also this part, or is it just...
every single thing.
Oh my gosh.
And so when the Orion people came, because they were building the heat shield for that, and they were wondering if they should go back to the same system, they tried a tiling system using the same materials so they could go faster, and that's when they had all those problems in the early testing, is because they started shearing off the tiles.
Wow.
So they might have to go back to
the original,
not individual filling, but the same type of application.
I love I'm seeing pencil marks right here.
Yeah.
Is that?
I don't know what that is.
It says roll B.
Rock B, yeah. Yep. So these are NASA markings, which I'll have to watch when we're cleaning it. You never know where you're going to find them. So these interesting things, which
what are these
engineering
doorbells?
Phenomenal. So this is the urine waste dump.
Oh, this specifically?
Yes, and it's covered in gold. So these are my favorite. Everybody wants to know what the 2 eyeballs are. And then when I tell them, they're like, oh my God. So they have these amazing, so they had a tube from the astronaut's waste dump, which was manually triggered. They have a tiny little heater right behind this inside this system, which heated up the liquid because they didn't want it to freeze on contact.
They didn't want it to freeze on its output.
Right, on the hole.
Right.
So,
yeah.
when they waste, and it's also the wastewater dump.
A urine warmer. And is there copper underneath? Is that why I see a little bit of green here?
There's like a copper frame, and then this is pure gold on top to keep it from actually freezing on contact.
Now, what's the reason that it was made so far proud of the
I think that's
surface?
where the heating mechanism is.
Oh, okay.
We're not quite sure. We have some pictures and technical documents on this, but no one really seemed to focus on it in any of the post-flight inspections or anything. So when you're doing your research, it's hard because I have these really intimate questions, and they're like, you're scanning through 500 pages of NASA, and they're like, don't even mention it. And I'm like, why not? This is so cool. So this is one of our favorite features.
That's amazing.
On there.
I'm curious about the silver here.
So that's Kapton tape as well.
Okay.
And they use that to keep more radiation off of it, more thermal properties. So that would have been underneath what you see on this boost cover. So this is actually a good picture of sort of the process of how they did the heat shield, which is interesting to me because I don't know if they were testing right here. I need to look at it a little more, but you wouldn't have had all these different surfaces. It would have just been one surface covered.
Monolithic.
Tape on, but NASA didn't peel that off. They peeled it off the other ones, so that's why they were brown.
Oh, okay.
So when it came back.
How come I'm just curious why I see so many more void repairs here than up here, but now I'm looking and I'm starting to see
This is also thicker.
Okay.
Yeah, and you'll see them if this,
Yeah.
when I clean it, actually, I'll remember to send you a picture. It looks like amazingly different when I use my cleaning technique to clean all this. I mean, you'll start to see a lot of stuff pop out.
That's so cool.
Yeah, you can kind of see them here,
Yeah,
you know.
yeah.
Or they drilled out like little worms to...
It must have been just weeks and weeks and weeks and weeks of...
Oh my God, I can't imagine. And this is some silver epoxy paint that they used to seal some of them. We analyzed that because we couldn't figure out why some of them had this sort of...
Now, when you analyze that,
painted
do you
cover.
send it to like a mass spectrometer?
We
Or
have
do you-
XRF here,
What's that?
X-ray fluorescence.
Oh, okay.
So it's portable, so I just shoot my gun at things. It looks like the Star Trek taser.
Yeah.
You know, like somebody who invented it, the portable one in the conservation field, came up with this tool.
Yeah.
I have not sent any samples out. I've done everything in-house.
Oh, okay. Oh, lovely.
We have FTIR upstairs too, which is Fourier transform infrared spectroscopy, also portable because we have big stuff, so we buy all portable equipment.
Right.
It's hard for us to take samples off things and feel good about that.
I would imagine.
So we often know that there could probably do a little bit more analysis. I'm still working on analyzing the interior paint coatings of the command modules because we had some flaking.
Right.
And they added a fire retardant to it, so it's basically a paint with no binder. It's
Oh,
all glass
interesting.
balloons, rods. If you look at it under the microscope, it's like
Right.
completely glass with a quartz pigment, which makes
Wow.
it look green. And so it's not staying on the walls as much. We're not having a huge problem, but we're
Yeah,
trying to
yeah.
anticipate. So we've done some research on that outside of house.
Does this one have the full instrument panels
I think
still
so.
in it?
I haven't been in there yet.
Oh,
so
wow.
yeah.
Oh.
I'm waiting. Next week I get to start doing my documentation. So
Is it sometimes hard? Do you chomp at the bit to get started, to get your hands on something?
I'm kind of excited because, you know, we've been working on spacesuit for a while now.
Yes.
And I kind of want to do a big cleaning, you know,
Yeah.
kind of get in there. But yeah, everything tells a different story. So I always get, you know, excited to start a new project.
I imagine.